Hello everyone, so this live session is for Edexcel IGCSE Mathematics B candidates, and since the syllabus content is way too huge to cover in one single live session, so I have selected probability. Today we will be solving the recent paper problems. I'm covering last five sessions starting from Jan 2020 to Jan 2022. 5 sessions we have so far, and I will be covering both the normal papers and the R papers. But apart from probability, if you think I should review any specific topic, you can let me know in the comment section. Because we have, I think, 7 or 6 days break before your paper to exam. Okay, so starting with Jan 20, almost all the questions are easy, but then again, we have this tricky problems from Jan 21 R paper. Then, so yeah, I will be covering from 20 to 22, in total 5 sessions. So let me start. So I have already uploaded this post where you will get one single PDF file that that will include all the papers of Math B, paper 1 and paper 2 from this year 2020 to 2022. So this will include all these papers. So I will be solving probability from this sessions. So far, I have uploaded one video on probability, so you can review the basic concept from there. So let me start. So this is from Jan 2022, paper 1. So number 23 from Jan 22. So this one is based on tree diagram. So for tree diagram, we know that it just basically shows you the options, right? So if you have 2 branches, it means you have 2 different options. If you have 3 options, then you will need you need to draw 3 different branches, right? And for each location, total probability should be 1. Total probability is 1. So all the probabilities of this branches are 1. Then again, the entire tree diagram, if you add all the probabilities of the entire tree diagram, this will also be total of 1. Okay, so for this 23 number math from Jan 22, Math B paper 1, we have this bag that contains 20 balls and each of them are labeled either 5 or 6. So they have mentioned that we have total, we have total 12 balls that are numbered 12, that are numbered 5. And then you have 8 balls that are numbered 6. So 12 balls which have labeled as 5, and then you have 8 that are labeled as 6. So in total, we have 20 different balls, and we need to pick we need to pick 2 balls from the bag randomly. So starting from the very first situation, if you select one particular ball from this bag, it can either be labeled as 5 or 6. So you have 2 different options. So that's why the branch started here as 5 or 6. So for any probability, if you need to actually calculate probability, it's just that you need to select the number of things that you are trying to find and then divide it by total number, right? That's the basic concept of probability. We need to actually check out the numbers. So when you are selecting the first ball, and if you want that to be labeled as 5, you need to check how many we have here. We have 12 different balls that are labeled as 5. So that's why 12 And in total, you had 20. So that's why 12 by 20. If you need this one, you can just deduct this 12 by 20 from 1, because total branch should be 1 here. So 1 minus 12 by 20. Or you can even select values from here, 8 by 20. Okay, so if the first one is 5, and if you select the second one and you want that to be 5 too, in that case, number of 5, initially we had 12, right? So now that you have already removed 1 from the back, number will decrease by 1. So we have 11 divided by total number will also decrease by 1. So 11 by 19. And if you need to find this value, since this branch will be 1, you can just deduct 11 by 19 from 1. So this one will be 1 minus 11 by 19. So that's 8 by 19. Similarly, if the first one is 6, and if we need to find the probability for the second one to be 6, we just need to check out the number of walls that are labeled as 6. So initially it was 8. Now that we have already removed 1, so it will be 7 divided by, total will also decrease, 7 by 19. Sorry. Okay, so this one will be 1 minus 7 by 19. You do not need to show this working. I'm just including this to make things clear. You can directly just substitute this values. So I'm done with part A, where we have to complete this tree diagram. And then for part B, you need to actually find the probability that the sum of the numbers on the two walls is greater than 11. Give your answer as a fraction. So we need to add the numbers that we get, and it should be greater than 10. That's the question, that the sum should be greater than 10. So if you select the first branch, 5 and 5 in total, the total score is supposed to be 10, right? Similarly, if you get 5 and the second one as 6, in total, you are supposed to get a sum of 11. If you get 6 and then 5, it's 11. If you get 6 and 6, it's 12, right? So that's how you can calculate the sum. So sum of the first branch is 10. For the second branch is 11. For the third, it's 11. For the last one, it's 12. Since we need to select those which actually gives us a sum greater than 10, it means you cannot take the first one. It's supposed to be the second, third, and fourth. So it has to be a combination of 5 and 6. This is the branch I'm talking about, 5, 6, or 6, 5, probability of 6, 5, or the last one, 6, 6. Once we have already selected the branches of the tree diagram, then you can just pick the values and multiply them, right? If you need to select this branch, you just need to multiply these values. As in, when you're moving along the branch, you need to multiply the values. So 12 by 20 into 8 by 19. Then 8 by 20 into 12 by 19. And the last one is 8 by 20 into 7 by 19. So this will give us a value of 62 by 95. But then again, since we have already seen that we need to exclude the first branch only, right? We need to select second, third, and fourth. We need to select 3 different branches, and we need to exclude only the first branch. So you can even use the shortcut method, that since we know the total probability is 1, right? Total probability is 1. So we can just deduct the branch which we are supposed to exclude, the first one. We do not need this branch, right? So if you deduct 5, 5 from the total probability, obviously you are going to get the sum of the probabilities of the remaining 3 branches altogether. So this is a shortcut method where you can just use the first branch. 12 by 20, 11 by 19. So that's also going to give us 62 by 95, which is our answer. So I'm done with Math B Gen 22 paper 1. So you can take a screenshot of this. That's the solution of number 23 from this paper. I will be moving on to the next year, which is I will be starting the year 2021. So the next year should be Jan 21. Okay, so this one is number 14 from Jan 21. They didn't included any tree diagram or Venn diagram, but depending on the situation, you can draw either of them. If you need to solve, if you need a diagram to solve that. For example, in this one, if we draw a Venn diagram, if we draw a tree diagram, it will make it easier. For example, in this map, this person actually travels by car or train. So you have two options, car or train. And then it says the probability of going to the work by train, then on a random day, probability she will be late for work if she goes by train, probability of being late if she goes by car. So see, you have, at the very beginning, you have two options, car or train. And then comes this second stage where you can be late for the journey, or you can go there on time. So this type of situation can be expressed in a tree diagram, right? So you can either move by a train or a car. If you go by a train, you can be late or not late, as in L prime. If you go by a car, still you can be late or not late. So I will just include the values now. Probability that she will travel by train is 0.1. So this one will be 1 minus 0.1, right? So 0.9. If Jill travels by car, probability she will be late for work is 0.05. So by train and late, this late portion we are talking about. So this part will be 0.05. And L prime will be 1 minus 0.05, that's 0.95. Then if you go by a car, you'll still be late 0.01. So car late. So this value is given. As in, they have given us the probability of being late, but two different values. One for the time when you are traveling by train, and the second one is for the situation when you are traveling by a car. So this one is 0.01, and this value 1 minus 0.01 will be 0.99. Then again, this you do not need to include this working. So I will just deduct them. I will just remove this. So I'm done with the tree diagram. Now that we are done with the diagram, we can start the math. We need to find on a random day, she is late for work. So this is a given that situation. As in they have already mentioned that she is late for work, right? So at the very beginning of the math, you need to find the probability of being late. So the first branch and the third branch, as in train late, car late. So I will be selecting values from this branches. So this one and this one. So you just need to multiply them. Along the branch, you need to multiply the values, and when you're working taking all the branches, different branches, you need to add them up. So it's basically 0.1 into 0.05, and then car, so 0.9 into 0.01. So this will be 0.014. And we have to calculate the probability that she worked by train on that day. She travels to work by train on that day. So we need to find the probability of going to work by train. So this is the branch we are talking about. But you cannot stop at train because they have already mentioned that she was late. So it means you have to continue up to this late point. You cannot just stop here just because they have included the word train here. Given that situation, already mentioned that she is supposed to be late, and then later on they want us to find the probability of train. So probability of train, and given that she is late, right? So we are talking about the first branch. So probability of train and late, that's what we are trying to find, divided by, given that situation is late, so you need to divide the whole thing by probability of late, which is 0.014. And at the numerator, you need to pick this branch. So that will give us 5 by 14. So remember, whenever you have an extra condition, in that case, you need to divide that value. That's your new total actually. So I'm done with Jan number 14 from Jan 21, paper 1. Next, we have this very important math, which is from Jan 21 R paper. So I will be starting this one, Jan 21 R paper number 25. So this is a question of IGCSE Mathematics B, Jan 21, paper 1R. So this one is from this chapter probability, number 25 from Jan 21, paper 1R. Okay, so in this question, we have actually 12 marbles in bag A and 15 marbles in bag B. So you have two different bags, bag A and bag B. Next, in bag A, we have 7 yellow marbles and 5 red marbles. So as I have already included in this diagram, you have 7 yellow marbles and 5 red marbles, making a total of 12 marbles in bag A. And then for the second one, you have 10 yellow marbles and 5 red marbles. So number of yellow is 10 and number of red is actually 5. So the total number of marbles in bag B is actually 15. Okay, so now we are selecting one marble from bag A without looking at the marble. It is then the marble is then kept in bag B. So we will be selecting one marble from A and then you need to move that to bag B. Then you need to select one marble from bag A and then 2 marbles from bag B. So 1 from A, 2 from B. In total, you have 3 marbles and you need to keep them separated. Find the probability 3 marbles on the table have the same color. Okay, so way too many information, right? So let me just summarize the entire thing here. So basically, we have two different bags, bag A and bag B. At the very beginning, you need to move one marble from bag A and you need to move that to bag B. After that movement, you need to select 1 from A and 2 from B. In total, 3 different marbles. So you see, we have 2 different stages. At the first stage, you need to shift 1 marble from A to B. And at the second stage, you need to select 1 from A and 2 from B. In total, 3 marbles. So this is the scenario. So the problem is that we do not have any idea when you are shifting the first marble from bag A to B, we do not have an idea whether it's a yellow marble or a red marble. So that's why we will separate the entire thing in 2 different stages. As in, we will continue solving in 2 separate scenarios. At first, we will look at this like when you are shifting from bag A to B. Suppose you are shifting a yellow marble. In that case, number of yellow will change in both bag A and B, right? But what if the first marble removed from bag A is actually red? In that case, number of red will be different in both this bag. Red will decrease from bag A, whereas number of red will increase in the second bag. right? So that's the problem here, that we need to analyze two different situations. So starting with the very first one, let's assume that when you are selecting one marble from A to B, it's a red marble, okay? And the probability for that is, when you're shifting one red marble, the probability is that 5 by 12, red is 5, total is 12, so it's 5 by 12. Next, when you are selecting three marbles, so when you're shifting this red, the probability is 5 by 12, and that will obviously change all the numbers, right? Now in this bag, we have 7 yellow marbles, but the red has decreased by 1, right? So we have 4 red marbles. In total, you have 11 marbles. And for if you shift a red marble here, if you shift one red marble here, in that case, we will have one extra red marble. So yellow will be 10, but red will increase. So in total, we have 16 marbles in this bag B. So now we will just start solving this map. So in this situation, I'm selecting that the first marble is actually red. Red from A to B. And then after shifting this one, we will be selecting three marbles, right? One from bag A and two from bag B. So these three marbles can be red, or this can also be yellow. We need to consider both the situations here. So I will be thinking about three red marbles first. And then we will repeat the same process, as in red from A to B. And then all the three marbles are red, yellow, all yellow, 3 yellow marbles. Okay, so next I will be using the values. So the first marble removed is red. Okay, and then the 3 marbles I will be selecting. Let's assume that all the 3 marbles are red. So red, red, red. So the first movement is 5 by 12, as discussed before, 5 by 12. And next we will be selecting 3 marbles. From the first bag, you need to select 1 red marbles, and number of red is now 4, and total is 11. So 4 by 11. From bag A, we will select 1, and from bag B, we will select 2 marbles. Sorry. So from the second bag, we are selecting 2 red marbles. So we need to check out the number of red in the second bag. Number of red is now 6, total is 16. So 6 by 16 into, the second one is also from bag B, right? So 5 by 15. Number of red will decrease by 1, and also the total number will decrease. So this is the first phase where you just removed one marble from bag A and then replaced it in bag B. And this 3 part is selection of the 3 marbles, 1 from bag A and 2 from bag B. So that will give us a total of 5 by 264. Similarly, if I select red at the very beginning, but then all the 3 marbles are yellow, so I will be using that value. So the first phase is 5 by 12, it's fixed, so I will be using the value directly. But this one, I need to check, right? 1 yellow marble, now we will select 3 yellow marbles. So the first yellow marble from bag A, number of yellow is now what? 7 by 7 is number of yellow, total is 11. So 7 by 11. And for the second bag, we have 10 yellow marble and total is 16. And then yellow, right? So these 2 marbles are from bag B. This is from A, these 2 are from B. A, B. So number will decrease by 1. So that's 9 by 15. So 35 by 352. So here's the situation. We, in the first phase, we just removed one from A and then we moved that to B. Then again, you have two options. When you are removing from bag A, one marble from A and two marbles from B, these three marbles can be red, 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 or yellow, yellow, yellow. They just mentioned us that the marbles have to be of the same color, but they didn't specifically mention which color we are talking about. So I have used red, 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 and yellow, yellow, yellow. I will repeat the same process, but this time in the first phase, when we just moved one marble from A to B, we will consider that this time it's yellow, not red. So I will just remove that portion. So at the very first phase, we will just remove one yellow from bag A to bag B, right? The first phase is that we need to remove one from A to B. And then you select one from A and two marbles from B, in total 3 marbles. So this can be red, 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 or yellow, yellow, yellow. So it's the same situation we have covered here, but right now we will consider that the first marble removed from A to B was actually yellow. So this time so the first yellow, when you are removing the yellow from here, initially yellow was 7 and red is 5, total 12. Yellow is 10, red is 5, total 15. So this is the very beginning, initial situation here. So if the first marble removed from bag A to B was yellow, in that case probability should be 7 by 12, right? Number of yellow divided by 12. If you shift one yellow marble from bag A to bag B, obviously this will increase the number of yellow, right? In bag B. So now number of yellow is 11, red is fixed 5, so in total 16. And one yellow marble will decrease from bag A, so this will be 6, red is 5, total 11. So these are the three new count of the marbles in each bag. So the new situation is that yellow from A to B, the first phase, and then 3 red, or suppose 3 yellow. 3 yellow. This is one situation. Or yellow from A to B, then 3 red. Okay, so yellow, then all the 3 yellow, marbles are yellow. So this one is the first phase, which is 7 by 12. And this 3, first time you need to pick from A, and then the 2 marbles are selected from B. So when you are selecting yellow from A, number of yellow is actually 6. Divided by new count is 11. For the second bag, number of yellow is 11 divided by 16. Then you are selecting the second marble from bag B, so numbers will decrease by 1. So this will be 10 by 15. So eventually we will get a value of 7 by 48. And this part is yellow, and then the 3 marbles are red. So the first phase yellow is fixed, 7 by 12. Then you need to select 1 red from bag A and 2 red from bag B. So when you are selecting red from bag A, we have 5 divided by total is 11. From bag B, number of red is 5 divided by 16 into red will decrease, total will decrease since you're selecting this 2 from bag B. So this will be 35 by 1584. So I'm almost done. All the values are given here. Now you just need to add these 4 values. You just need to add these 4 final values to get the answer. So probability of same color. So it will be the sum of all these values. R, 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 then R, yellow, 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 then all the yellow marbles, and then yellow, red, red, red. As in all these 4 boxes, you need to add them up. So the final result should be 907, 3168. So this is the complete solution of Jan 21 paper 1 R number 25. So in this problem, we had 2 separate stages. At the very beginning, you are selecting just 1 marble from A and you move that to B. This is the first phase, and it can be yellow or it can be red, as discussed here. We have separated this entire thing. What if the first marble from A to B is red? This is the situation. And what if it's yellow? That's the second situation. And once you shifted the first marble, then we will select 1 from bag A and 2 from bag B, and that has to be the same color. So red, 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 or yellow, yellow, yellow for both this situation. So yeah, that's the end of number 25, Jan 21, paper 1R. Next, this is October 21, Math B, October 21, paper 1. This one is easier compared to the last one. This is actually easy. We have this tree diagram. So we have these 2 games, chess or snooker. So probability of winning chess is given. In that case, losing, not win. You can get that value by just using 1 minus this formula. Total probability is 1. So you can just deduct this from 1. That will give us 0.65. And then probability of winning snooker is given. Probability she will win the game of snooker is 0.48. So this branch is for winning of this game snooker. So 0.48, 0.48 on both this space. And then you can just find this one, which will be 0.52. Okay, so probability of winning a chess is given, probability of winning a snooker is given, and they are independent of each other, as in snooker should be 0.48, 0.48 on both the situation, irrespective of what happens in the game of chess, because they are independent. So I'm done with the tree diagram. Next, we need to find that she will win only one of these games. So if you win chess, in that case, you will lose in snooker. If you lose this game, in that case, you need to win the second one, as in 1 winning and 1 losing. So probability of 1 win. So win prime, this branch, or W prime and W. I'm referring win as W and not win as W prime. So this branch is actually 0.35 into 0.52. Then the second one is 0.65 into 0.48. So this will give us a value of 0.494. So that's it. That's number 26 from October 21, Math B paper 1. Next, so we are done with year 2021. Okay, so this is from Jan 22. Then we solved Jan 21 and Jan 21 art paper. Next, it's October 21. Now we are left with only 2020 papers. So this is Jan 20 paper 1, number 26. Like I said, you can either use a tree diagram or a Venn diagram depending on the situation. In this case, it's easier if you work with a Venn diagram because we have 30 people here, and some travel by train, some travel by plane, and there are some who are traveling by both train and plane. So since we are working with both train and plane, it's an overlapping situation, right? Train and plane, so the common portion. So it's always easier to work this kind of problems using a Venn diagram. So I will be using two circles, one representing the train and then plane. So we do not have any idea how many people are in this common portion. So I will just denote it by X. But traveling by train is actually 15. So this total circle T is supposed to be 15. You cannot just write 15 here because the total T is supposed to be 15. So this portion is actually 15 minus X. Similarly, 9 is the total plane portion, so 9 minus X. And 12 did not travel by either of this, so 12 is outside the circle. So at the very beginning, I will try to find the value of X. Since I know the total number, I will just add all these values from this diagram. 15 minus X plus X, 9 minus X equals to 30, since the total number is 30. So solving this will give us a value of 6. Next, in this question, 3 people are chosen randomly from those who travel by plane. So this is kind of a given that situation that it's already mentioned we are working with the people who have traveled by plane. So you need to select from the people inside this circle P. You cannot use this 30 anymore because we are not selecting from all these people. We are actually selecting just from the plane. So this total is here. So total plane was what? Total plane was 9. So from this 9 people, some traveled by plane and train, which is 6, right? X is 6. And so this from this 9 people, traveling at plane, we have 6 people who have also traveled by train. And the remaining 3 are T prime. So we are trying to find 3 people, and the probability should be exactly 2 of these people also travel by train. So 2 of them will travel by train, and then the third person, it's T prime, didn't travel by train. But this values have to be from this 9. Total is supposed to be 9. So T is 6 divided by 9 into, when you're selecting the second time, number of people traveled by train decreased, so 5, because you have already selected one person here, right? So the total will also decrease by 1. And T prime, we had 3 people who didn't travel by train, so 3 divided by total decreased by 1. But then again, you cannot we cannot say that the third person will be T prime. It can be T prime T T or T prime T. So as in this prime, the position of this prime, the sequence is not mentioned. So that's why we have 3 different sequence here. You can place T prime at the very first position, second position, or third position. So instead of solving this thrice, I can just multiply a 3 with this entire thing. So the answer should be 15 by 28. Next, so this was from Jan 20. Jan 20. Next, we have this from May or October 20. So we have this spinner where in the spinner we have 5 different sector. It's labeled as different colors. And you cannot just think like probability of orange is 1/5, probability of blue is 1/5. No, it's not. It's a biased 5-sided spinner where probability of different colors are already given here. You need to use those. We have those values missing. Probability of getting a pink or yellow. So they have already mentioned that probability of the spinner landing on each color is given. Probability of the spinner landing on orange is 3 times probability of spinner landing on pink. It means they're saying that probability of orange is 3 times of probability of pink. So we can assume the probability of pink to be x, right? So in that case, probability of orange should be 3x. And now that we know this probabilities, total probability should be 1. So I will just add them up. 0.2234, 1, 2, x and 3x. That should be equal to 1. Solving this will give us a value for x in this equation. So x is 0.08. So this is the probability for what? Pink. So probability of pink is 0.08 and probability of orange is actually 3x. So 3 into 0.08, so that's 0.24. So I will just include these values in this table. So we are done with part A where we just completed this table, and then we just, after spinning this once, we get that the probability that it will land. Okay, so we do not know how many times we just actually spun the spinner. So number of times you have already spun the spinner is actually unknown. Let's assume it to be n, and it will land on green is 90. So you are spinning this a lot of time. You do not have any idea. Let's assume it to be n, and the number of times it will land on green is actually given 90. So how can we actually find the probability of green? If we need to calculate the probability of green, in that case, it's supposed to be number of times the spinner actually landed on green divided by number of green divided by total number, right? So total number is unknown. Let's assume it to be n. Number of times it actually landed on green is 90 and probability of green is 0.12. So solving this equation will give us the value of n, which represents actually the total number of times you spun the spinner. So n is 750. So this is number 27 from May 20 Math B paper 1. Okay, so we're almost done. This is the last problem of probability related problem from this recent sessions. So this is number 7. So we have 10 different cards, and in this 10 different cards, we just use these letters from this word Piccadilly. We just included each letters on each of these cards, and then you are selecting 3 of them. What is the probability that you will get P on the first card, A on the second, and L on the third in that order? So you do not need to actually change the sequence or something because it's already fixed. You need to select P, A, L in this order. So for the first card, when you're selecting P, we need to check we have only one card that represents P. Total number of card is 10. Card is 10. For the second one, we need number of cards that represent A, which is 1. Total card will decrease, 9. For the third one, it's L. So we have 2 different L here. So L is 2 divided by total will decrease by 8. Decrease by 1, that's total is 8. So the final result is 1/360. That's it. So we just covered the probability related problem from the recent papers. And this one is the most important one here. Okay, so we just covered the probability problems from Jan 2020 to Jan 22, as in 5 sessions. And we covered those problems just from the paper one. Okay, so I might actually list out the important problems from paper 2. So we will see that in the next live session. So till then, take care. Bye-bye.